Recording in progress.
Hello everyone, I'm Winnie. Today we're going to discuss on this Physics SPM Trial 2024 Negeri Sembilan Paper 1. So questions 1. Which of the following is a derived quantity? So firstly, we need to know what is meant by derived quantity. Derived quantity are those physical quantity which are derived from the basic or fundamental quantity by multiplications or divisions. So for your information, we can classify physical quantity as derived quantity and also base quantity. So for base quantity, we have altogether 7 base quantity. Okay, whereby you all can go through the idea from the textbook again. We have what? Temperature, length, time, current, amount of substance, right? In mole. Okay. They use the symbol N, then luminous intensity, IV, okay, and also mass. So altogether got 7. Okay, so those that not belong to base quantity will be derived quantity. And this derived quantity, simple idea, example is like when we have the idea of length time length. Okay, then we have this concept of L squared, which is referred to area. So this is the idea of derived quantity. So like a period of oscillation actually refer to the idea of what? Time, which is base quantity. Then displacement is the idea of length. Okay, like radius, all these, they are all classified as length idea. So they are also base. So that's why these two is not the answer. And then temperature itself, like just now teacher mentioned, is also the idea of base quantity. Okay, so force. Okay, so why force is derived quantity? So for information, okay, from chapter 2, from 4, you have F equals to MA. Right? M is mass, mass is base quantity. Then acceleration, for whoever know the idea, is actually rate of change of velocity. Okay, whereby you see the idea, if I use the unit, it will be easier for you all to capture. So mass is in kg. Then acceleration is in meter per second per second. So we have the idea, the operation for multiplications and also division between what? The idea of mass in terms of kg, and then meter in terms of length, and then s per square. So this is the idea of time. So this is the concept of derived quantity. So our answer is C. Question 2. Diagram 1 shows the difference in diameter of Earth. All of the following statements about gravity on Earth are true, except, so they want to find the one that is wrong. Okay, so what is the idea behind it is there is slightly different in terms of the diameter between the pole and also the this what we call it as this equator. Okay, so equator is teacher find pictures which easier for you all to capture. So is the idea on this side to this side. So where their length is 12,756 km, which is slightly longer compared to the pole. Okay, so then how do we get the gravitational acceleration? So from chapter 3, you're all supposed to learn a formula where you relate the idea of mg equals to g m1 m2 over r square, right? Then you cancel out, you're supposed to get g equals to gm over r squared. So as you know, if your r is actually longer, that means your g is less. Okay, so we can actually calculate the gravitational acceleration at this equator. So what you do is you basically sub into this equation. Okay, so we sub, we go and find out whether the value is true for A or not. So our G is actually a constant value. If they did not give you in the questions, just mean it will be in the formula. So for information, capital G is 6.67 times 10 power of negative 11. Then the mass of Earth is 5.97 times 10 power of 24. Okay, all this is actually constant. They're supposed to give you in the formula list. Okay, and then we sub the value of this R. So the R here is half of this value. half. So you divide by 2, because they want the equator, right? So that's why we take this, okay? The length on here. So after you divide this value by 2, you're supposed to get 6378 kilometer. Then we did change it to meter. Okay, so everything is in SI unit. Then the whole thing have to square, So again, as usual, your press calculator, you're supposed to get 9.788 meter per second. So that's mean it's correct lah, but they want the answer that is wrong ma. Okay, then move on to idea B. The distance from the equator to the center of Earth is longer than the distance from the pole to the center of Earth. So this distance is indeed longer because equator is longer compared to this one. This one is slightly shorter, right? Because this value is smaller. So again, this is also the true idea. Then C, the value of Earth gravitational acceleration G changes from one place to another place. Correct lah? Okay, if you were to sub the half of this value into this equation, you will surely get slightly different answer as the value of here is smaller so your value of G is slightly higher. Okay, so but they want the one that is wrong, wrong idea. So the value of G at equator is greater than the pole. So this is not true because your equator is longer. So that's why the G value is supposed to be smaller. So the answer is D for question 2. Number 3, the force acting per unit mass is actually referred to what? Okay, is actually refer to the idea of gravitational field strength. Okay, so what you all learned in this weight idea under chapter 2, right? We have this F equals to mg. So we rearrange G will equals to F per unit mass, okay, force per unit mass. With their unit, force is Newton, mass is kilogram. So that's why you have Newton per kg. So this idea is called gravitational field strength lah. Okay, and then another quantity we actually have the same unit is called gravitational acceleration, but in terms of definition, that is slightly different. So if you define force per unit mass, then this is referred to gravitational field strength. If you want to use the idea of gravitational acceleration, then we always say it's actually about object fall due to acceleration. Okay, number 4, diagram 2 show a Formula 1 racing car. The car used material with low density in the construction. Why? So for your understanding, when the mass low density means the mass will be what? Low. Well, okay, then based on this Newton's second law of motions, right? It states that what? Okay, acceleration is inversely proportional to mass of an object when the force is constant. So which means if your mass is less, what happened to your acceleration? They will move faster. Okay, so from the option here, A is the answer itself already. Okay, smaller mass produce larger force, not true. And then larger force, larger inertia. So it's not what we want now. We want the idea of low density, low mass. And then a composite material with low mass reduce the cost, not about the mass idea. It's depending on the material. Okay, light material may be expensive as well. Number 5. A follow-through action with a constant force on a stationary object can change all the following, except which one? So, of course, you all need to know the idea of follow-through is always related to what? Related to impulse. So, impulse symbol J. So, impulse can be changed in momentum or the idea of force time, force time. So, all this quantity will be changes lah. Okay, as you can see, impulse is not the idea. Okay. And then the time of contact also not, because when the idea of follow through means is example like you hitting a golf ball. So you need to have this action or you swing the golf club, right? And then you hit the ball, right? So during the idea of this follow through, you're actually increasing the time. So your purpose is actually to increase the final velocity. And then finally, you also cause the impulse to increase lah. Okay, so final velocity also have to be changed one. So that's why this is not the answer. Okay, and the answer should be initial momentum. Why is initial momentum? Because initially when you start to swing the golf club or any equipment. Okay, so basically your initial velocity is zero. So that's why there is no change in initial momentum. Question 6. A radar imaging satellite orbit around the Earth at the height of 525 km. What is the value of gravitational acceleration at that position? So to get the answer, you're supposed to know the formula for gravitational acceleration, which is what? G equals to gm over r squared. Okay, so for your information, G is a constant value and is here. And then mass is also a constant value. But be careful about the idea of this small r. So I normally show using diagram easy for you all to capture, okay? So basically, the satellite is somewhere over here, satellite. So the question given is only the height of this satellite from the surface. But whenever we calculate, right, this r is referred to the distance from the center of the Earth to the satellite itself. That means we are getting the distance from here to here. This is called what? R. So that's why what we need to do is, generally this r, you have to find a side first. This r is actually the radius of Earth. Radius of Earth from here to here, plus the height. So once you get this idea, then you can sub and then you can get the correct idea. So we can find out the r aside first, or you actually can straight away sub into the equation as well. Okay, so we can straight away sub lah. So G, capital G is what? 6.67 times 10 power of negative 11. And then we time with the mass of Earth, 5.97 times 10 power of 24. Then divide by the sum of the Earth. So the R here is 6.37 times 10 power of 6. And also be careful. Giving here is kilometer. So what is kilo stand for? Kilo is 10 power of 3. So I will write 525. Then add 3 more 0 lah. Then the whole thing, bracket and square, must remember to square. So normally this topic, the teacher will say, student may know the formula, may put the value inside correct, but sometimes you may press the calculator wrongly. So it is a good practice, like now also, okay? You just try out, press the calculator. You don't just listen, okay? It won't help out, okay? So when you press, you get the same answer. So that means you get the correct idea. Also, the answer for this question is D. But you press calculator, you write everything same like teacher, but wrong. That means the way how you press calculator may have problems. So you may need help from your friends or to show you how to press the calculator. Once you know the idea, then it will be easier already. Question 7. Diagram 3 shows an astronaut floating on the moon. When the astronaut landed on the moon in 1969, there was spacesuit and carry pack of heavy equipment. On the moon, astronauts would weigh 6 times less than they do on Earth. So which statement explains the situation correctly? So the mass of astronaut is smaller on the moon. Okay, so for information, this idea also relates a bit on weight idea on chapter 2.8. So generally, you all need to know the differences between mass and weight. So mass generally is always constant and everywhere one. Okay, but our weight is it will be changes when they are at different positions. And W equals to mg. Okay, mass is constant, right? So the thing that changes is actually the gravitational acceleration or gravitational field strength. So why it is 6 times lesser? Because on moon, right, there will be smaller in the value of G. Is how much smaller? 1/6 compared to on Earth. So nothing to do with mass idea. And then mass of the astronaut should also not be correct idea. And just now teacher already said the strength of gravitational field strength should be lower, not higher. So it's wrong as well. And the moon gravitational pulling force is smaller. So this is the idea lah. So they are in whole the idea of the weight or the force between the two objects. Number 8, which statement is correct about Kepler's third law? So under this 3.2 gravitation topic, you need to know 3 Kepler's law, first, second, and third. So what is the third law idea? Is actually different planet that orbiting the sun, okay? They will generally orbit at different radius, and hence the orbital period will also be different. When they are further, then the orbital period is also longer. So where they come from, this Kepler third law said that what? The square of orbital periods of any planets is directly proportional to the cube of the radius of its orbit. Okay, in short, T square directly proportional to R cube. And then from here, you also can derive the equation that become T1 square over R1 cube equals to T2 square over R2 cube. Okay, number 9. Diagram 4 shows a cup of hot coffee. What will happen when the coffee and the cup are in thermal equilibrium? So the concept of thermal equilibrium is when two objects, okay, in thermal contact, at the end, what happened? The temperature is same. And then the next contact is the net flow of heat is 0. Net flow of heat is 0. So this is the concept of thermal equilibrium. So A, the temperature of cup is increasing. So not correct, but at the end, they must be same. Decreasing, also not correct. This is not reached thermal equilibrium yet. And there is no net heat flow from the coffee to the cup. Yes, this is the correct idea, or vice versa. There's no net heat flow from the cup to the coffee as well. Okay, there is a net heat flow. So the word net, it means after you sum up. So it means like, okay, the coffee, let's say I give 10 joule to the cup. So the cup will also get 10 joule. So the net is actually 0. There is heat flow, but the net heat flow should be 0. So there shouldn't have any heat flow, okay, in between. So the answer is C. 10. The latent heat of fusion of water is heat absorbed. So for information, latent heat is the heat that involved when there is a change in state. And then fusion is actually, the idea is from ice to water or vice versa. So your idea is absorbed. So that means is for melting. But it's for 1 kg of mass without change in temperature. So not 1 meter cube lah. So B, C, D also not correct. C and D is C, the idea is related to specific heat capacity. So this is the definition of specific latent heat of fusion. Quantity of heat that is absorbed during melting or heat that released during freezing of 1 kg of substance without change in temperature. Question 11. Diagram 5 shows a lead block, an iron block, and aluminium block. All the blocks have the same mass and heated with same amount of heat energy in 15 minutes. The specific capacity of each metal is different. So which statement is correct after 15 minutes? Okay, so general idea, the idea about specific capacity, the definition itself is actually the heat needed to increase the temperature of 1 kg of substance by 1 degree Celsius. So if you have a bigger value, that means is towards the idea of heat insulator. They need to supply more heat, then they increase the temperature. If the value is small like this lead, okay, which means you supply a little bit of energy, they actually increase the temperature by 1 degree. That means, in short, it heat up faster. When the value of C is small, they heat up faster. This is the concept. Okay, so let's check what happened after 15 minutes. So obviously, like teacher say, because you supply less heat, that's why the lead block will heat up first, then followed by iron block, then finally only aluminium block. So they say the lead block have the lowest finest temperature. Not correct idea lah. Okay, then next B, the aluminum block have the highest final temperature. Not aluminum, is lead, right? So also wrong. The final temperature of the iron block is equal. Same, also cannot, because supposedly lead is higher. The final temperature of lead is higher than the final temperature of iron. Yes, this is the true statement. Question 12 from chapter 5, electromagnetic wave. So diagram 6 below show wave electromagnetic spectrum. Which physical quantity increased from radio wave to this gamma ray? Okay. So for information, radio wave have the longest wavelength, whereas gamma have the shortest wavelength, but they have an inversely proportional relationship with the frequency. Okay, radio wave generally have the lowest frequency, but gamma ray have the highest frequency. So from radio to gamma, so they will increase in terms of the idea of frequency. Number 13, a ship sent an ultrasound whose echo is received after 2.2 seconds. If the wavelength of the ultrasound in water is 0.05 meter and frequency is 50 kilohertz, what is the depth of the ocean? So under this topic or this reflection, particularly for sound wave ultrasound, okay, you have this formula. I will tell students easy to remember. 2D equals to V times T, or D equals to V times T divided by 2. Okay, so based on this idea, question given, you got the idea of time. You do have the idea of this distance and this frequency. Sorry, this is wavelength. Wavelength. And then this frequency. Okay, so they have time, but they do not have the idea of this speed. Okay, so why they give you this wavelength and frequency? Because you generally can find out the speed using another formula, which is what? V equals to F lambda. Then when we have this, then only we sub into here. So this question, lengthy a bit long, okay, but a bit long, you need to apply two equation. So now we can sub long. Now before you sub, again, check out, is it everything in SI unit? So kilo is referred to what? 10 power of 3. So that means 50,000 times 0.05. So you calculate this and get the answer first. You're supposed to get 2,500 meter per second. So once you have, then you can find the depth, which is 2,500 times 2.2, and then the whole thing divided by 2. So at the end, you will get the answer 2,750 meter. So the answer is A. Question 14. Parallel wavefront incident on a slit are diffracted. So which combination of wavelength and size of slit will the diffraction affect the greatest? So firstly, you need to know what is meant by diffraction. So diffractions is when the wave pass through, they will spread out, okay, pass through a slit, or even they're around an obstacle, okay, they will spread. So for information, if the gap of the slit is small enough, or the wavelength of the wave is bigger than the size of the slit, so when they pass through, they will become circular. So when they become circular, which means the idea is what? Obvious, okay? Obvious, the effect is greatest lah. But why versa, if let's say we have another idea, okay, because easier for you all to capture the idea. We have now bigger gap. Bigger gap, and make the gap even bigger. And it's actually bigger than the wavelength. So I'm using the constant, which is now same wavelength idea. Then what happened when the wave pass through light? They will just bend at the edges only. Or they will just slightly bend. Okay, of course, wavelength, all this will still remains unchanged. Okay, they just bend at the edges. Some sort look like this one. They come out straight lah. Okay, so let's see the options. Short wavelength, not true. We want long wavelength. Then next thing, the slit should be what? Narrow. Wide cannot. So that's why the correct choice will be C. Question 15. Diagram 7 show a ray path. Which path A, B, C, and D show the correct propagation of light as its enter medium Z of greatest refractive index? So for your information, if the refractive index is high, that means the medium is also optically denser. So among air is less than medium, Y is denser, but Z is the highest density. So when ray travel from less than medium denser, they will actually bend towards normal. Okay, so like this case, air to Z, if no bend, they will just go straight, right? So they bend towards normal line. Then from here, same thing. If no bend, they'll just go straight, right? But they're towards ma. So obviously your answer is what? A for these questions. Question 16. Diagram 8 shows a ray of light propagate in a transparent semicircular block. What is the possible refractive index of the transparent block? So this idea where the ray do not actually bend away from normal is because they encounter a phenomenon called what? Total internal reflection at this point. Total internal reflection. So for total internal reflections occurs, they have two conditions. One, ray must be travel from where? From denser to less than medium. Then next idea is your incident angle must more than critical angle. Okay, so what you can do is you can basically find out what is the refractive index of the medium, or whereby, okay, we can relate it with this equation, n equals to 1 over sine C. Okay, so if your angle, this 37, is more than the critical angle, that means the ray will show this idea. But why versa, if you get the angle of I less than critical angle, that means they won't have total internal reflection. The ray will just encounter refraction. Okay, so they give you the refractive index, so you can actually sub one by one to find out, okay, what is the critical angle of the scenario, which means example, now I try for A first, A. So you will have 1.25 equals to 1 over sine C. So sine C equals to 1 over 1.25, and I want C, so you press your calculator, shift sine this value. So supposedly the idea for A, you will get this 53.13. Okay, so this 37 now is actually called incident, you know. So 37 versus 53, is it more or less? Less. So that means it's not happen. Means total internal reflection not occur. So it cannot be 1.25. Then you do the same thing, but now you press a calculator for B. Okay, C equals to shift sine 1 over 1.33. Then for B, you're supposed to get 48.75. It's still not possible. Understand? Because still less than that. Then for C, shift sine 1 over 1.43, and you get 44. It's still big. Okay, and finally, if you were to put the calculator for the ideal option D, right? C equals to sine, shift sine 1 over 1.66, you actually get 37. Okay, supposingly, if this I equal to critical angle, right? The correct drawing is the ray supposed to reach 90 degrees. Okay, but of course, there's no other options. So that's why the best answer is D only. A, B, C confirm not happen one because refractions of her. Okay, number 17. Diagram 9 show an object placed in front of a concave lens. So which position is the image for? Okay, so I always tell students when you all learn about the ray diagram, right? Okay, for lens or mirror, you firstly need to know or identify what is the phenomenon occur. So lens memang is what? Refraction. And then not only you know about the phenomenon, the next thing is the ray converge or diverge after the phenomenon? So concave lens, the ray will actually diverge. Okay, so I just go through with you how should you construct the ray diagram. So from object, you got ray that touch the axis of lens. Then what happened? Because their refraction, so the ray will pass through. But should the ray diverge or converge mean like this, diverge mean go up. So like I mentioned, it's supposed to be diverge. So we will use the focus point on the left-hand side as reference. So dotted, go up. Okay. My dotted because the ray not supposed to exist lah, this part. What you will actually see in the actual scenario is the ray will just pass through. And then the next ray that you construct for this concave lens is you cut through the center. So the intersection point is where my image forms. So obviously my answer is B. Okay, so hopefully you all know how to draw ray diagram for concave lens. So concave lens, no matter your object is at what position, you will always have the similar way of construction, and the characteristic of the image is always virtual, upright, and diminished wood. Okay. 18. Diagram 10 shows a cross-sectional area of a concave mirror with a bulb used in a car headlamp, and the distance between the bulb and the pole of the spherical mirror is D. Okay, so at which position will produce a parallel reflection of light? Okay, so this idea, you need to know well about the 6 different position of object in front of the concave mirror. Okay, so to produce parallel ray is actually if you always follow teacher's idea is this case 2. Okay, I always tell student if this is your mirror concave or convex lens, then when you actually construct ray diagram, they will have 6 different position. Okay, so for mirror 2F is same as C. Okay, so you will actually have the idea where your object is less than focus point. Then at focus point between F and 2F, at 2F, more than 2F, and also at infinity. Then we have these 6 cases lah, 1, 2, 3, 4, 5, and 6. And the characteristic is womb, rim, wrist, rid. So this is applicable for convex lens as well, not only concave. This one wrong already, is mirror, okay? Or convex lens. Okay, so how the idea of this case 2 produce parallel ray is any ray that they cut through focus point, right? Okay, so example, now teacher just show you off straight away. Any object that cut through the focus point, they will actually parallel up. Okay, I cut through focus point, I touch the mirror, I will have parallel ray. Cut through focus point, parallel ray. Cut through focus point, parallel ray out. Okay, so that's why the idea is what? D must be equal to focal length. Diagram 11 show 3 horizontal force act on a car that's moved along a straight leveled road. Which combination of force would result in the car moving at constant velocity? So the constant velocity is a very important term. Constant velocity means the object where they are acted by zero net force. Okay, so which means your frictional force or anything that on backward sorry, this is by the way, okay, I write wrongly. This one, the forward one is called thrust. So I put the symbol thrust. And then you have this frictional force and also drag air drag. Okay, air resistance. Okay, so if that force 0, that means the value over this side should be equals to the sum of the value of this side. So therefore, you see lah, which idea after you sum up will be equals to 1,500 lor. Okay. So you have this, right? 1,000 plus 500. So it's answer already lor. You see 500, 500, not correct. 1,500, 2,500 already ma, not 500 also ma. 1,000, 2,500, okay? And then it's not correct as well. 20 is Form 5 elasticity topic. Diagram 12 below show a spring with original length of 250 millimeter. The spring is compressed when a weight of 3 kg is placed on top of it. What is the compression of spring in meter? They just want the idea in meter. So actually the question is a direct question. So also when you are subjected to a 3 kg mass that have been compressed to become 200 mm, right? So the compression or extension, they're using the same symbol is actually 250 mm minus 200 mm lah. Then you get 50 mm. So for information, you need to know what is mean by milli only ma. So milli is 10 negative 3. So 50 times 10 negative 3, basically your answer will be what? 1, 2, 3, okay? 0.05 meter. So this question is considered direct lah. Okay, for question 21, diagram 13 shows a weight lifter athlete lifting two load A and B, which have the same weight. And T is the pushing force exerted by the weight lifter's hand at the angle of T with the iron rod. So which diagram is correctly represent the force acting on the athlete? Okay, so this idea is under forces in equilibrium, okay, whereby when he lift up this weight, right, he is not moving, right, at rest. So at rest, the concept-wise, the net force is 0, equilibrium. So first step, actually, you need to draw the idea of what? Of this free body diagram first. So the 2W weight is always acting downward, so in short, okay, but they have 2 weight on both sides. So this weight in total is 2W. And then the one that push the weight up is the hand applying the force with an angle. Okay, so to complete the triangle of forces, right? So I will tell students, you all like playing the toothpick like that, or matches, okay? You just need to rearrange, but you cannot change the direction of the force. So my weight is downward, you cannot make it horizontal. So in short, I put up here. So I can complete the triangle. Notice or not? Like this. Or vice versa, I also can complete the triangle like this. Okay, so assuming I use this, whichever also same. So this is called tension, this is called tension, this is 2W, but the angle in between must be how much? 60, because 30 plus 30. Okay, so actually out of here, there is no option. A is wrong because this one's supposed to 2W. C is wrong because the angle should be 60. B and D is not acceptable is because my weight is not horizontal. My weight is not horizontal. So that's why actually this question memang no option lah. The answer tak ada lah. So for information. Okay, 22. Diagram 14 shows the liquid spurting out of the hole at the same depth. Which of the following comparison is true about the density? So for information, the formula for liquid pressure, P equals to H rho G, where rho is the idea of density lah. Okay, and the spurting distance is represent the idea of liquid pressure as well. If they are further, that means the liquid pressure is higher. So for your information, the relationship the deeper the depth, the higher the liquid pressure. The higher the density, the higher the liquid pressure as well. So why the X spurt up highest? That's why the density of X is the highest. Then followed by who Z and then followed by who? Followed by Y. Y the density is the least. So you check which option is the correct answer for 22 that have the same idea like what teachers show. So it's D, yeah, so the answer for this question is D. Okay, 23. Diagram 15 shows a glass lifter used to move a piece of glass as a construction site. How does the glass lifter work? Okay, so this concept is under the idea of gas pressure, or it's just like rubber sucker or plunger, right? So when you press it, you force the air out. So causing the pressure inside is low, pressure is low, but then outside the atmospheric pressure is higher. They will push the glass lifter towards the glass lah, and then they will stick on it. Okay, so let's see the option. The lifter created a cohesive force between the lifter and the glass. So they didn't mention about the air pressure idea, all this. Also, this is still not the good answer yet. And then next, the atmospheric pressure outside is less than. Cannot, right? Just now I explained already, it should be more than. See, the lifter create a vacuum space between the lifter and glass so that the atmospheric pressure is greater. Yes. Also, when I press out the air, so it can be partial vacuum or inside, it's totally vacuum as well. Okay, so the answer is C lah. Okay, now D also cannot because they say the atmospheric pressure is smaller. 24. Diagram 16 show a constant floating, a coconut floating in the sea. What will happen to the buoyant force and weight of the water displaced when the coconut enter the river mouth? So initially they are floating in the sea. Sea, okay, what is so different between sea and the river water? So generally, the difference is about the idea of this density. So the water at river mouth is a lower density. Okay, so but do you change in the weight of this coconut? No, right? So generally, if let's say the coconut is still floating in the river mouth, okay, so this is the idea. So in the Archimedes idea, we also can relate with resultant force. Okay, whereby what is the force that act on this coconut? Okay, the force that act of the coconut is buoyant force and also weight. So in this context, they're supposed to be equal. Okay, and then what y'all learn about this weight of object lah. Buoyant force is also equals to rho v g, which is a weight of liquid display. So when the coconut enter the river, this river now. So what happened? Okay, I resketched the diagram. So supposedly this coconut, it will actually submerge more. Okay, why? Okay, so because when the coconut is at seawater, rho Vg, so the density is higher. So the displaced liquid will be less. This volume of liquid displaced. But then when they are in the river, so your density is lower, so you need to submerge more, displace more water to support the same buoyant force. Okay, as buoyant force is what? Same, constant. Okay, so buoyant force. Wait, I'll let you check the answer. No change. And then here they are giving the idea of weight. So weight of the water display also shouldn't change. So the correct answer is B. Now what I'm showing you is the idea of volume. Let's say the question got volume of water. So then you all can give the answer based on teacher's explanation. Okay. Why the buoyant force no change? Because they are floating. Okay. Then buoyant force is same as weight. Okay, and then buoyant force also same as weight of liquid displaced. That's why that doesn't change as well. 25. Diagram 17 shows a recreation activity known as parasailing, where a person is tied behind a speedboat while tied to a canopy wings. What caused the canopy wings to lift? Okay, so this idea is related to Bernoulli principle, where Bernoulli state that what? When the speed, okay, in a fluid, air or liquid lah, okay, is high, then the pressure is low, or why? side. So why they can lift it up is because the speed on top of the canopy should be high, right? And then the pressure is low. But vice versa, beneath the speed is low, pressure is high. So that cause a lifting force. Okay, so let's check the option. The airflow velocity is higher on top than below. So this should be the idea already. Then we check all the options as well. Because sometimes even though A is correct, maybe you have other answer which is more accurate. Understand? Sometimes correct doesn't mean it should be the choice already. So go through all as well. The air pressure is higher on top. No ma, it's lower. Okay, the airflow lower on top, likely wrong lah. Okay, then the air pressure is higher on top, also not correct. So confirm is A already lah, the answer. 26. Diagram 18 shows a bird perched on a high voltage cable and the bird does not experience electric shocks. So which of the following statement is true? Okay, the body of the bird have high resistance. Yes, indeed. That's why it won't flow through it. The resistance of cable from R to S is very high. Cannot like high, that means the bird memang burned already. Okay, then the current through the body is very high. Also cannot, okay? The potential difference across R and S because they are small enough, okay? So that's why the correct answer is 1 and 4 lah. 27. Diagram 19 shows 3 identical resistors connected to a cell of 1.5 volt. So which of the following is correct comparison? So they just draw the idea to just slightly confuse you all, okay? So it's good that if you all can do the same thing like how teacher do, you redraw the idea and then you put the idea like normal setting. Normally we all draw all the resistor in parallel way easy to capture. So if I redraw the idea, this is how you can see it. This is your A1. Then you have your A2 and your A2 here got 1 resistor. And then lastly, here got 1 resistor, 2 resistor, and then only A3. So you see I redraw the drawing already. Okay, so is the current same? Okay, so for information, this is parallel circuit. So in parallel circuit, that means the idea of the main current I total is equals to I1 plus I2 lah for information. So for information, your current will flow from the positive. Then upon this point, right, they will split to all certain current to the respective path. And then they will join back at this point. So actually A1 is having the total current, the main current. So A1 supposed to be the total. Okay, then A2 and A3, the comparison. So you see here got 2 resistors. Here is 2 R, here is R. So when resistance is high, current is lower. So that means less current will be flow through A3 compared to A2. So A1 is the highest one. Then followed by A2, then followed by A3. Okay, hence your answer will be A. 28. Diagram 20 show an electric circuit. Which of the following pair is correct if an identical dry cell is added in parallel to the electrical circuit? Okay, which means now what you do is you add another battery. Now since battery in parallel, so the function is like they won't change the idea of the EMF one because they are parallel, which means initially one battery I have 1.5, right? So now I parallel another is still no change. So that's why actually you can have the answer, okay? But why internal resistance is lower because parallel, so we will have the 1 over R equals to 1 over R1 plus 1 over R2 idea. Then I want R, then you inverse the answer later on. So supposedly your total internal resistance will be lesser than. Okay, so your answer is D lah. 29. How far apart are 2 parallel plates that have an electric field strength of 3 times 10 power 3 volt per meter between when the potential difference is 15 kilovolt. Okay, so for this idea, you all need to recall back the formula for electric field strength. So generally, you have two formula for electric field strength. One is for a point charge, another one is for the parallel plate. So for parallel plate one, for point charge is equals to force per unit charge. Then for the parallel plate is the voltage potential difference is to the distance between the two plates. So we are using this one now. So they are giving you the idea of this E and then also V. Okay, but you need to find what is D. Okay, so we rearrange the equation. D equals what? V over V. V over E. So your voltage 5 kilo. 5 kilo means 5,000. And then E is a correct unit over per meter. So straight away, 3 times 10 power of 3. You just sub inside. So finally, you will get the answer for D. Okay, the answer for D will be 5 meter. Okay, move on. Question 30. So which diagram show the correct combination of force when two current carrying conductor, straight wire conductor is placed in the magnetic field? So this is the idea that under the concept of motor, because changing what? Okay, you changing the idea of electric current, the electrical energy to what? To kinetic energy idea. So more is located on left side. That's why you're using Fleming left hand rule. Remember, is if the other concept which is 4.2, then just say I will always use dynamo as idea. Okay, where there are vice versa idea, they are changing kinetic energy to electrical, or you induce EMF. So the more is on the right, that's why you use the right hand Fleming's rule. So now we focus on this one. So we don't see this one. So let's see our FBI. So make sure you use the correct hand first. Okay, so again, people who are not sure what is dot and cross mean, dot mean what? Dot mean up. Cross mean into the screen. So like assuming now you're all learning together with teacher on the computer screen. So FBI. So this the thumb is force. V is magnetic field. I is current. So I fix the current. Then only I twist and turn my magnetic field and find out is the force idea correct for A or not. So FBI, I is into the screen. So everyone point away from yourself. And then how teacher move the north to south idea? So I will rotate like that. So once you fix the current, right, you cannot turn your hand anymore. You must only turn your north-south or rotate clock or anti-clocks. So I will do until like that. See or not? So my thumb is where? Towards left. So that means this idea memang wrong already. So either this or this. Can? Okay, then next, dot, FBI. I is pointing out. North to south, so like that. So now you see my thumb memang is this way. Okay, so in terms of force idea is correct, but is the pattern correct or not? So why do you have this force idea? So for your information, the force idea is due to the stronger field to the weaker fields. It is from strongest field to weakest field. So you see the line here is more than here. So B is the correct answer. You see this one cannot, because this one is more line, this one is less. Okay, so the answer is B. Okay, next we have question 31 under the concept of electromagnetic induction. So diagram 21 show the situation where a bar magnet move away from a solenoid, and then the pointer of the galvanometer deflect to the left. Okay, so how do you get the idea is, first, the current, the deflection show towards left. That means your current is come from X. Okay, you push it, then that move to the left. And then we can actually use the right hand grip rule to get the idea one. Right hand. So again, everyone use your right hand. So I tell student, okay, you complete the arrow on the solenoid first, the current. So when you're using your right hand, right, this is your forefinger, and this is your thumb, correct? So this thumb is referred to North Pole. This time is north. Then you curve up, you see your current is up. Notice or not? So that means this is north, this is south. Okay, so if the magnet is away, that means this polarity is opposite polarity because you want to attract back. Okay, okay, if towards then same pole So P is south pole, round already lor. The current is induced from X to Y. So indeed, based on what I draw is correct idea already. The deflection decreases as the magnet move faster. Cannot lah. When you move faster, the deflection also higher because this is referred to Faraday's law, more cutting. Now, this scenario, because you are determining the polarity. So it's not about Faraday's law, it's about Lenz's law. So the answer is B lah. Okay, proceed. We have question 32. Which energy change take place during electromagnetic induction? So just now, teacher also got elaborate on the idea. So electromagnetic induction is the idea of the production of EMF when there is a change in the magnetic flux in the conductor. So you need to have motion. So the idea of when you have movement, motion of involving kinetic energy is called mechanical energy. Then you will change it to electrical energy. So the answer for 32 is C. 33. The efficiency of a transformer is 75%, and the input voltage of the transformer is 220 volt and produce 0.4 kilowatts of the output power. So what is the current in the primary coil? So under the idea of transformer from 5 topic, chapter 4 electromagnetism, you only learn a few formula for transformer. One is about the number of turns in the voltage, right? And then if ideal, then output power equals to input power. And lastly, the formula for efficiency, this is a symbol for efficiency, is output power divided by input times 100%. So basically, you have the efficiency idea 75%. Then for the idea of output and input, right, depending. So sometimes we can change the idea of power become VI or E equals to VI physics, very important. Okay, up to you, okay, as long as you remember this idea. So, but this is given one is output, so they already give you output, so you don't need to change to VI, okay? So, you remain the output same, but then input is VPIP. You can change it, okay, to this idea. So they're giving you the input voltage and they actually want you to what? Find the IP. Notice this is the one that I know, but I have all this already. Notice now I can sub into the equation. So 75 equals to 0.4 kilowatt means 400 watt lah. So I change to SI unit 400 over 220 IP, then times 100%. So slowly do your maths lah. Pindah. So you have 0.75 equals to 400 over 220 IP. Then IP swap with 0.75. Then you get your answer lah, supposedly 2.4 to 4 ampere. Okay. So move on, we have question 34. So diagram 22 shows an electronic circuit. What is the function of the transistor in the above circuit? Okay, so a transistor have two functions, acts as automatic switch and also act as this current amplifier. Yeah, so in current amplifier, you do not have the top part which close up one. So this one is memang automatic switch. So our answer is C lah. Our answer is C. Okay, then 35. Which of the following property is cathode ray? So for information, what is cathode ray? Cathode ray is fast moving beams of electrons, right? Okay, so if it is electron, it's supposed to be negative charge. So positive charge wrong. Radioactive radiation also not correct. Okay, what you all supposed to learn in the nuclear energy topic or the radioactive radiation, you have alpha particle, beta particle, and gamma ray. And then cannot deflect by magnetic field, also wrong. So generally, these cathode ray can deflect by magnetic field and electric field. They are negatively charged, they move in a straight line, they possess momentum and have kinetic energy. Right. So D, yes, or kinetic energy convert to light energy. What they do is when these electrons, they move very high speed, then they hit the fluorescent screen, they will actually turn it to become green in color. So change to light already, lor. Okay, then 36. Diagram 33 shows a circuit consists of a diode and two bulbs. When the switch is on, the both bulbs not light up. Okay, why they don't light up? Because of the connection of the diode. So for information, diode, generally the function is to allow the current to flow in one direction. So this line part is called N-type. The triangle part is called P-type. So you see the connection, okay? If P-type connect to negative terminal, and then N-type connect to positive terminal. So this is called reverse bias. So reverse bias means the current will not flow. So they will stop the current from flowing. That's why the bulb not light up. But what if teacher change this connection, or now I don't make it N and P, I inverse it, whereby I make it become this way. So your N-type now connect to the negative, P-type to the positive. So this connection is called forward bias. So forward bias means they allow current to flow. Then hence the menthol will light up. So what we need to do is we just need to reverse the connection of the diode, or even reverse the terminal of the battery also can. 37. In the nuclear reactor, graphite is used as the moderator. What is the function of the moderator? So for information, moderator is used to slow down the fast-moving neutron, okay, in a nuclear fission. So the answer is B lah. Control the rate of reaction by absorbing. That one is called control rod. Control rod. So it's nothing to do with moderator. Block the radiation, also not the idea. The one that can prevent leakage is the lead or concrete, the concrete. The fuel is actually the uranium lah. Okay, 38. Diagram 24 shows a reaction that occur on the surface of the sun. Which statement is not true? Is wrong lah, okay? So this idea happened in the sun. So that means, firstly, you need to know this is actually referred to nuclear fusion. Okay, fusion only occur at a high temperature or high pressure due to, okay, by right, nucleus combine, it's not easy because they have same charge. Okay, so let's go through the option. A nuclear reaction, then small and light nuclei decay. It's not decay, is to combine. This reaction take place at high temperature and pressure, correct. Energy and one neutron are released each time these reactions occur. Mass effect also occur. Yeah, indeed, they will produce energy. So that means the answer is A lah. The one that not true. Okay, 39. All the following statements are true, except, again, they want to find the one that is wrong. So you have to go through all the idea, okay, to find out which one is wrong. Quantum energy is discrete packets of energy and not continuous, correct? So the idea of quantum energy is that we refer the light as a photon, like in the particle form, okay? Discrete lah, they are not continuous. And then next, a black body is a superior body that is able to absorb some of the electromagnetic radiation that fall on it. Yes, they are radiator and also absorber of this radiation. Then C, the photoelectric effect is a process where electrons are emitted from the metal when heated. It's not when heated, when they're hit by the light or light energy at certain frequency. So this is not correct idea. Threshold frequency, minimum frequency of photon that produce photoelectric effect, correct idea. Okay, so come to the last questions already. Diagram 25 shows a process that occur when light is shone onto a metal surface. So which of the following is true based on the process that occur in the diagram? So this is the concept of photoelectric effect. So again, we go through all the options and find out which one is the correct one. So photoelectrons are emitted if the value of the light frequency used is less than the threshold frequency. Cannot. It's not less, it must be more. Okay. So if the threshold frequency example 10 hertz, okay, so your photon, the light frequency must more than 10. You can, then only photoelectric is occur. If like less than 10, example 8, then there will be no photoelectric effect. B, the work function of the metal is a maximum photon energy required to produce the photoelectric effect. Also not correct. So work function of metal again is a minimum. What means it is quite similar like the threshold frequency, but you need the minimum energy. Okay, where to the light can cause the photoelectric effect. Okay, C, maximum kinetic energy depends on frequency of photon. Correct. So this idea is come from the Einstein equation where you have this photon energy equals to work function plus K max. So your kinetic energy increase, okay, when your photon energy increase. Where this photon energy sometimes is equals to HF as well. So that's why F increase, energy increase, K max increase. Okay, so the photon energy value is greater than the threshold frequency. We do not relate energy directly with threshold frequency like that lah. So that's why we will say the frequency, light frequency. So D is not that accurate as well. So that's why our answer is C lah. Okay, so I hope that you all will learn something again for this paper. Okay, so that's it for this Negeri Sembilan paper. Thank you everyone. Bye-bye.